Hello students and welcome back to the chapter 3D lines. In this module we are going to learn some interesting lines and interesting concepts students. The heading says skew lines and distance between parallel lines. Let us see the first two words, skew lines. So in skew line students, let's consider two lines L1 and L2 in a single plane. So let us start off by taking two lines in a plane. In a plane, any two lines may be parallel or intersecting each other. So let us consider these scenarios. Here is line L1, here is line L2. These are parallel or intersecting lines. Correct? So if somebody says there are two lines in a plane, we say the lines may be parallel or intersecting. Right? Now students, if we think of lines L3 and L4, that is two more lines. If you see the diagram, L3 is edge of the cube and L4 is a different edge of the cube. Now let us concentrate on these two lines. Lines L3 and L4 are non-parallel as distance between them is not constant. Right? Similarly, L3 and L4 are non-intersecting lines. Right? And if the lines are non-parallel and non-intersecting students, then such lines are called as skew lines. Okay? So, if we see the definition, the skew lines definition says non-parallel and non-intersecting lines are called as skew lines. Alright, so now we learned skew lines. Let us see what do we mean by shortest distance between lines. Let's draw perpendicular to both the lines. So if you see in the diagram, there is a perpendicular AB to both the lines. So it is 90 degrees with both the lines. And this kind of distance AB students is called as shortest distance between L3 and L4. So AB is the shortest distance. Alright. Now students, once we learned skew lines and shortest distance, let's try to find shortest distance between skew lines. That is, we are concentrating on AB. Okay. Let L1 and L2 be the two skew lines. So here we have two lines. L1 is passing through point A1 bar and parallel to B1 bar. So L1 has a point and parallel vector. So equation of L1 is R bar equals to A1 bar plus TB1 bar. Similarly students, we consider a line L2 which passes through a point and parallel to a vector. So in the diagram, we prepare a point B having position vector A2 bar and a parallel vector B2 bar. So equation of line L1 and L2 we have. Alright. Now when we try to find shortest distance, let us draw a segment perpendicular to both the lines. So here is the segment perpendicular to both the lines. Let us call this segment as PQ. Okay students, as PQ is perpendicular to both the lines, it is the shortest distance, right? Now when we try to find the shortest distance, we say PQ is parallel to B1 bar cross B2 bar. So PQ is parallel to B1 cross B2. Unit vector along PQ will be n cap equal to B1 bar cross B2 bar divided by magnitude of B1 cross B2. Now students, if you look at the diagram, when we join AB, we can say the shortest distance PQ is projection of AB on PQ bar, and therefore PQ is equal to AB dot n cap upon mod of n cap. This becomes PQ is equal to A2 bar minus A1 bar dot B1 bar cross B2 bar upon mod of B1 cross B2. Okay students, and therefore this shortest distance is given by box product of A2 bar minus A1 bar B1 bar B2 bar upon mod of B1 cross B2. Alright, this expression is the shortest distance. Right students? Now in note we say if Cartesian equations are given, that is first equation is in Cartesian, similarly the second equation is in Cartesian form, then students we can still find out shortest distance, and it is given by a magnitude or mod of numerator is a determinant. The determinant says x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2, and denominator is under square root. It is given by b1 c2 minus b2 c1 the whole square plus a2 c1 minus a1 c2 the whole square plus a1 b2 minus a2 b1 the whole square. So this expression is used when Cartesian equations are given. Okay, let us proceed. Now let us learn coplanar lines. If shortest distance between skew lines is 0, then the lines intersect. And condition for intersecting lines is the numerator part of the shortest distance has to be 0. Okay. Now students, if two intersecting lines are always in a single plane, then we say the above condition also indicates coplanar lines. Alright. Let us see for parallel lines. Consider line L1 and L2 which are parallel. So for L1 the equation is R bar equals to A1 bar plus TB bar. This line is parallel to B bar. Alright. Similarly students, let us consider L2, that is this equation. L2 line is again passing through point A2 and parallel to B bar. If they are parallel to same vector B bar, that means they are parallel lines. And then we say distance between parallel lines we can find out by using a letter D, and D is given by D is equal to mod of A2 bar minus A1 bar cross B cap, that is mod of A2 bar minus A1 bar cross B bar upon mod of B bar. So here we completed the module. Thank you.